Hello again and welcome to the first general session of the Fly ND Conference. We are excited and honored this morning to introduce to you Dick VanGrundsven, the founder of Van's Aircraft. We're greatly looking forward to hearing his story. Thanks for being here with us today, Dick, and it's off to you.
Hi, I'm Dick VanGrundsven, the founder of Van's Aircraft, and I'll be talking to you today a little bit about, kind of where we are, what Van's Aircraft is, and I'll start off though with a little bit of an introduction as to how this all originated. And I was not an aviation family like some people are. However, there was a little aviation background. Picture here of my father in the mid-30s, had learned to fly at a local airport, more of a grass strip, really backyard compared to most of what we're familiar with today. And he had learned to fly in this American Eaglet airplane, and I think soloed in something like 4 hours of dual, obviously not as complex curriculum as we have now. And immediately they transferred him into this single seat home built, which was really a historic airplane in some ways, but an airplane that flew well on its homemade engine. Dad only flew a little. Depression days, ran out of money, was getting married, obviously trying to support both at the same time didn't work too well. However, when I was young, myself and my slightly older brother were intrigued with aviation, and his recollection of these days of flying really impressed us and were embedded on us. So that we became teenagers, and my brother, being older, learned to fly. Fortunately, Dad was sympathetic, so went out and bought this J3 airplane that we were able to fly from the farm, which was really our livelihood, very small farm in Western Oregon. Put in this airstrip, which was 650 feet long, perfect approaches, seems like more than adequate for a Cub, which it was, but that said, a lot of Cub pilots probably couldn't manage it. Anyway, so after a short while, decided the Cub was too slow and managed to replace it with a Taylorcraft. And the Taylorcraft was not painted quite like this when we got it. My brother and I had to jazz it up a bit. And for those of you that remember the 50s or the 60s, you had to, well, particularly being teenagers, you had to add a little flash and pizzazz to something. So all of the checkerboard and such we added. The other I added was a set of wheel fairings, and you notice the white wall tires. Again, you have to be able to appreciate the appeal of that. The significance here, though, is that the wheel fairings are something that I made a mold, made fiberglass molds, got a supplemental type certificate on that at age 18, and started manufacturing them. I only mention that, it just gives a little bit of background as to you might say, entrepreneurial or engineering bent that I had. At that time, I was just starting my engineering education at the University of Portland in Oregon. I went into the Air Force. I'd gone through the ROTC program at the university. Was not on pilot status, but I managed to acquire a dismantled airframe from this old Stitz Playboy. It, as I say, was non-flying, so I spent a year and a half restoring it to that configuration with a bubble canopy and a slick cowling and a 125 horsepower engine, which was a lot of power for that time. And gee whiz, a set of wheel fairings that look vaguely familiar to the ones we just saw. I had that airplane for a while. It flew well, had enough power to provide quite a bit of performance, but still not really what I realized was possible. So I designed and built a set of aluminum cantilever wings to replace the strut-braced wings on the original airplane. That then I renamed the RV-1, and this photo was several years further. I refined the cowling and a few other things, got to this level. 1968, get my years straight, 1968. An airline pilot in Texas wanted it real bad, so I sold it to him. It gave me an excuse to turn around and design a new airplane, the RV-3, based on that already successful airplane, but with totally aluminum, not a hybrid anymore, all aluminum wings. Basically what I had already developed, a new fuselage, tail surfaces, just overall refined. Every step along the way, the performance went up. And one thing about this photo, we see that airplane that just kind of, with the shape and all, that speaks of speed, but parked at our short farm runway. This, I guess, is kind of the origin of the term total performance that we've used throughout our career at Van's Aircraft, but this is kind of how it all got started. Now, with that as a background, we'll just kind of move into where we are today, and this more of the evolution of the Van's Aircraft and our designs as we moved along. With me here is Greg Hughes, who's been with Vans for several years now, our head of marketing and things. Pardon me for not knowing the exact title.
They call me the director of everything else.
Right. But basically put together this presentation, and I'll let him take a few slides here before I pick it up again.
And folks, we'll apologize for the camera situation just because of current inoculation status and social distancing. You know, we're staying a little bit apart here. So, Van's Aircraft is approaching 50 years old. Van, I think the company was officially founded in, well, it's either 72 or 73, depending on how you look at it.
Well, the actual name was registered prior to that, but as far as starting to market plans and kits for airplanes, 1972, 73 was about the era. So we're approaching 50 years.
So Vans is a company that's been built on a strong, consistent tradition over that entire period of time and has grown. I know I started a few years ago, and I think there were 65 or 68 employees when I joined total, and now we're close to 100. So the last few years have been very, very busy for us. And, the RV aircraft line has really evolved and changed. And, these are some slides that we often use. It shows like Oshkosh or Sun and Fun and similar, but, the company has developed, and Van has designed, and others, with Van have designed, aircraft along the way, starting with that RV-3. And in a little while, Van will go through the evolution of the different designs, but it's gone from single seat to two seat to side by side to 4-seat to light sport and on. And the kits have really changed over time as well. But when people are thinking about the airplane and which one really works well for them, we usually talk about it in terms of mission, right? What kind of flying are you looking to do? Some people want to go upside down. Others are really into flying formation. A lot of people kind of want a plane that'll get them from here to there that they can have fun in, but then will also, just reliably and quickly get them from one place to the other. Some folks just want to take an airplane every now and then. They just want to go up and fly around and see the changing leaves, or go to the coast, or whatever, go fly over a hill.
Or all of the above.
Total
performance.
And so the idea is that there really is an airplane for pretty much everybody in the fleet. So one of the things that people will usually consider is, what do I really need in terms of what can go in the cabin? How many people need to fit in there? Is it, is it one? Is it two? Is it four? What do I need to take with me? How much stuff, baggage, pets? A lot of people like to fly with their dogs and whatnot. So the cabin requirements, is it a tandem or is it a side-by-side? Do I really need 4 seats? How much do I need to carry, and what volume and weight is that, is part of what goes into the conversation. Also, when thinking about mission, one of the key mission components is, how far do I want to be able to go? Now, of course, you can go as far as you want if you're taking off and landing and putting fuel on, but as far as filling up with fuel and going nonstop, what do you have for requirements around that? And one of the many aspects of total performance, again, is how far can I go and how quickly can I get there? Another one is, am I going to fly just as a day VFR pilot? If I'm a sport pilot, I'm flying day VFR. If I'm a private pilot, I might be flying day and night. I might or might not want to fly IFR. How do I want to equip the airplane? And also, how much do I want to spend in equipping the airplane? So we allow a wide variety of choices and options when it comes to doing that. Really, for almost all of the kits, you have those choices that you can make. And then, as we mentioned, aerobatics and going upside down, and things like formation flying, and even putting formation and aerobatics together sometimes. There are quite a few really talented teams of individuals. This is pictures you're seeing here are a team from South America, and they're just super talented and do really amazing stuff. And so we're really excited and proud of the people that have taken RVs and done really cool things with them. Now, not everybody does this, but one thing about the community and the RV community is that it's a very passionate community of people that build and fly our airplanes. So there are a number of basically never-ending debates that go on amongst airplane owners and especially RV owners, and one of them is tricycle versus tail gear. Another one would be primer, right? Do you prime or not prime, or which primer do you use? But what it comes down to is, it's a highly personal choice. Several of our models are available either as a conventional tail dragger gear style or as a tricycle gear airplane. Another of the total performance characteristics that really defines RVs is the fact that, generally speaking, they can go quite fast, but they can also fly quite slow, and can both take off and land in fairly short distances. And that enables folks to be able to take their airplanes and go to short strips in Idaho, for example, or to land on the grass strip on the farm, and to do those kinds of things. And especially as people become more and more proficient, then they have the ability to do that. And then the next one is ease of construction. How difficult is it to put together the airplane? And forgive me, I'm going to try to dismiss this thing. All right, there we go. Is it difficult to put together? Is it relatively easy to put together? And how much time and what level of skill is required?
Okay, well, maybe I'll pick up here a little bit. Well, we're kind of starting at the end and working backwards, I guess. There's a representation of one of our current kits, just depicted in portions, so that you get an idea of kind of the building progression, the normal progression, starting with the empennage and tail group of the airplane. It's a reasonable place to start because typically simpler components, less expensive, better to make errors on small pieces than big pieces. It's part of the learning process, though, that normally progress through the airframe from the tail section to the wings, to the fuselage, to the power plant. And again, this has evolved over a lot of years and has proven to be an effective way to do it. with the kits being available in the components sections, you don't have to pay for everything up front. You probably buy as you go, which obviously makes a lot of sense for a home builder in that don't always have the budget to. One reason you're home building is you don't have the budget to buy a ready-to-fly factory-built airplane anyway. So it all meshes together pretty well in concept and in realization. Backing up to our earlier designs, the RV3, 4, etc. When we started, aircraft, as we know them now, didn't really exist. Most home-built airplanes were just built from blueprints or drawings and raw material. Hard to imagine now, but hey, that's the way it was. A lot of the airplanes were simpler because while they had to be working from raw material, it difficult to do a real complex airplane. Thus, though, as we evolved initially, the plans I drew had to be mechanical drawings, large prints, usually 24 by 36 size, with all of the detail that was needed to build the airplane from raw material if you chose. Very soon after starting to market the airplane, and initially the single-seat RV3, we developed a kit package that had some of the components and basically all of the material and hardware necessary to do it, but still the drawings had to be very detailed so that the builder could work from the basic kit. The plans have evolved over time as the kits have evolved, in that the current kits have most of the components are completely built. So it's more a matter of assembly than construction or that it had been many years ago. Therefore, the plans have evolved to the point that they're more of assembly drawings without all of the detail and intricate dimensions necessary. So, and a lot more detail. Initially, things like the throttle assemblies were kind of left up to the builder because he was sourcing, in many cases, sourcing from the salvage yards and what have you. Now, everything, every component down through all of the engine controls, et cetera, is provided with a kit. So we have very complete drawings showing all of the detail so that we can ensure more consistency on all of the vital components. The other, over time, the industry has evolved to the point that kind of meeting customer demand, the kits have become more complete, and to the point that some pre-assembly is done as much as is permitted under FAA rules to comply with the major portion required for amateur-built licensing. So we have what we call the quick build kit, which in the lower photograph shows the quick build versus the standard kit. The upper drawing, in this case for the RV7, pretty typical of all of our planes though. All of the individual components as they're manufactured and supplied. Then in the quick build kit, some of the assembly has been done again up through the about the maximum permitted by FAA rules. The other is that Van's aircraft has evolved to providing builder support. Obviously, good kits, good instructions are important, But building an airplane is a big job. I don't care how simple the airplane is or how good the kit is. A lot of times I like to compare it to an aircraft factory where the builder is really performing all of the work that the entire assembly staff at Cessna might be doing. So it's unreasonable that this person is going to be able to work through this process without some questions and some assistance. So we have several people on the staff here at Vans that via email or telephone can answer questions, help people over little challenges they have. The people that we have on staff for that are all pilots. In most cases have built their own airplanes, so they're well qualified to offer this sort of help. And the other, even though we may have had a kit on the market or online for a number of years, we are constantly upgrading as the opportunities present themselves, or as they're as we become aware of ways for making improvements. And so again, over that almost 50-year period of time, we've created a line of aircraft. We'll kind of go through now how some of this evolution came about. We started out with a single-seat RV-3. I explained a little bit in the introduction how that came to be. And primarily it was an airplane for myself that met as much as possible my desires in an airplane, which were pretty broad. Obviously, I wanted a fast airplane for cross country, really was into aerobatics, had a background flying from short strips on the farm, being able to literally keep the airplane at home. A lot of desirable features that I wanted, incorporated those as well as possible into this airplane. At that time, a lot of the home builds, the majority leading up to that, had been single seat. So even though a single seat is now kind of the exception, it was a reasonable starting point, both to keep the costs down, to keep the assembly, the building time down, etc. It didn't take long. Obviously, the airplane was appealing. We had offered plans for it, and I mentioned within a couple of years some form of rudimentary kits. But almost immediately, of course, people wanted more than one seat, which is understandable. It's kind of reluctant to do that because wasn't sure that I could retain the performance and all of the qualities in a bigger, heavier airplane. But at some point in the mid 70s and started developing a two-seat RV-4, you can see the similarity between the two. And it just made sense that if we knew what worked, we didn't stray too far from the well. We made the two-seat as much of an expansion of its smaller predecessor. Fortunately, we mentioned before in the case of the RV-3 that we had to provide construction drawings for the airplane that had all of the detail necessary to build from raw material if desired, or from the basics that were provided with the kit. And that was pretty well true through the period that we had offered and the RV-4. The two-place, by the way, it became much more popular than the single seat, which again, probably is understandable. But that brings us into the early 1980s. But I guess if I wanted to sound like I'm complaining, as soon as we had that, then a lot of people wanted side by side. I had chosen the tandem configuration for the two-seat just because I felt that it had I could make the lightest airplane that way, the cleanest, the lowest drag, and get the maximum performance. Was concerned that with a side-by-side airplane, at least some of the examples that were available at that time didn't really have the overall performance capability. Felt there'd be too much of the sportiness and the ultimate performance lost. But that said, after a few years, realized that needed to give that a try because of the desirability and the functionality of side-by-side seating. So we created the RV6, kind of patterned after the tandem RV4, but reconfigured fuselage. Technical difficulty. So then the initial was the RV6 tail dragger, getting into an era where fewer and fewer pilots had tail wheel experience, that had not learned, most had learned to fly in tri-gear airplanes. And so we developed I guess we didn't have it there, the tricycle variant to the RV6, which we call the RV6A. That established a pattern then of the tri-gear models. Variation of any of the designs then had the A designation. So that's the reason for that. Eventually we had really great success with the RV6, but as time moved on and we were able to make upgrades and other proposed upgrades, we developed the RV7, which was overall a very similar configuration, very similar in size, but had offered a little more of everything, really, a little more horsepower, higher horsepower option, a little more fuel, which gives you more range. But primarily, we were making upgrades in the design, the actual construction of the airplane, or the kits themselves. We were able to manufacture components to a more complete degree, making it easier to assemble the airplane. So we created the new designation rather than just an altered designation. The RV7 was really the first kit that we had that offered what is now commonplace for all of our newer designs, which is matched hole construction. Thus, all of the pieces with rivet holes, attached holes, already in place, so that it really became more of a function of assembling the airplane than fabricating as it had been in the earlier days. So this is really what set a new course for our company, that we were able to offer that, and the 7 was the first model. And it seemed like with each upgrade, it just enhanced the appeal and the market segment for the aircraft. When we did the side-by-side RV6, it immediately became more popular. It almost put our tandem RV4 out of business. And it seemed obvious that maybe that was the future, forget about the tandem airplane. But I still had a kind of a warm spot in my heart for the tandem arrangement. I liked the idea of centerline seating for doing aerobatics and formation and such. So this was about the mid 90s, I guess. One of the appeal of the side-by-side airplane was just better cabin ambiance, comfort, space, etc. And the RV4 had been designed way back in the mid 70s. Expectations were a little different. People were a little more willing to compromise space and such for, well, the sportiness of the airplane. Really, the thought behind the RV8 was to take a tandem configuration and incorporate as much space and cabin comfort as possible. We did that. I'm very glad we did, because the airplane, while never achieving the bestseller status, has gained a real solid following and just remains a popular airplane. The one thing about the RV8 is that it actually preceded came on the market before we had completely evolved the matched hull manufacturing capability. But over time, we upgraded the airframe so that it, like the RV7 and 10 and 14, does have a complete matched hull tooling for ease of assembly. The RV9 is, I don't know what not a stepchild necessarily, but one that came into being in the late 1990s. And kind of the thought behind it was our other airplanes, the RV4, particularly the RV6, were sometimes seen to be a little bit more challenging to fly than the trainers that people had learned in. Not necessarily hard, but quicker response rates and lighter controls. Just took a little bit more adaptation, I guess, to fly well. The idea for the 9 was to make an airplane that flew more like a trainer, that had a little lower landing speed. And initially, the thought really was to fly on lower power, both for less expensive and burning less fuel. So we took the fuselage from almost the same as an RV6 and incorporated a longer, narrower wing with a better flap and reduced the stall speed by 6 or 7 miles an hour, which in the real world makes it feel like you're flying at half the speed. You just have a lot better reaction times and such. As it turned out, while we had a 118 horsepower Lycoming 0235 in the prototype, that's really what the airplane was designed for, with 160 horse upper limit. Turns out that people want more performance and are willing to spend more money, etc., than I had sometimes thought. So it's become the more popular engine for that airframe. And again, it's was a non-aero because of the longer wing. And just the mission of the airplane was not intended to be aerobatic, so it doesn't have aerobatic strength and more of just an ease of flying entry-level type airplane. It has had a steady following over the years, and well, as with the rest of our airplanes, found a real market niche. This airplane differed a bit and had a unique proprietary airfoil that was designed by aerodynamicist John Rauntz to try and achieve the best qualities for the specific mission of that airplane. One of the requests we'd had for many, many years was a 4-seat airplane, kind of along the lines of more is better in all respects. We kind of hesitated because for a couple of things. One, all of our two-seat sporty airplanes were really filling a void in the market. The factories had never really built any airplanes, any significant number of high-performance sporty two-seat airplanes. Four-seat airplanes, pilots had a choice of quite a number of good performing, used, affordable four-seat airplanes. Also, we knew more than a lot of prospective builders do, that building a bigger airplane was going to be more of a challenge and that it was going to be an obstacle. However, as we evolved into the ability to simplify the construction through the matched hole tooling that we've incorporated in the kits, that along with just the fact that the used airplanes were getting more used and less available. In 2003, we test flew the prototype of the RV-10 four-seat airplane with designed primarily around the Lycoming IO540 260 horse engine. Turned out to be a very capable airplane. Again, we had a proprietary airfoil used on the wing that intended to offer the best performance for a high-speed load-carrying airplane. And as indicated here, the kit had matured to the point that we had all pre-punched matched hole tooling, and the instructions for this airplane. Then we evolved away from the large mechanical drawings or so-called blueprints to instructions that were more suited strictly for assembly, more of the step-by-step, all of the drawings and the text accompanying side-by-side on the plans. And I forgot to mention that in the case of the RV-7, the big advantage in building was that unlike the prior airplanes, you didn't need assembly fixtures or jigs to hold all the pieces together as you fitted and drilled and riveted the skin. So that was a big advantage, that you basically can assemble all of the, basically hundreds of pieces, and they self-aligned because of the accuracy at which we were able to pre-punch and form all of the parts. Following that, or actually during the time that we were developing the RV-10 and updating our manufacturing capability, the light sport licensing category came into being. We kind of did not get in on absolutely the ground floor because we were busy with other things, but as we found time subsequent to developing the RV-10 and upgrading everything else, that we designed the RV-12 Light Sport to give that a try. It's a little different in that we obviously, with the light sport category, as most people know, there are limits on weight and speed, primarily, so that we designed the airplane so that it would be as easy to build as possible, require less tooling than the others. Thus, the primary structure is all fastened together with pop rivets, blind rivets, rather than typical AN rivets. Initially, the RV-12 we designed it around the Rotax 912 100 horsepower engine. And after a few years, Rotax had developed the fuel-injected, electronically managed 912 IS engine, so that we redesigned the airplane to use that engine, a bigger not necessarily compromise, but adaptation than one might imagine, even though it was the same basic engine. So we did that. It required a number of changes in the fuselage and other things we'd learned. We incorporated other upgrades into what is now the RV-12-912IS. Kind of during the same time that we're upgrading the RV-12, we developed an RV-14. Well, the 14 looks a lot like the 7 in the background in this picture. And a lot of people ask us why we did that, why we made another airplane. We already had a successful line. Part of it was that nothing is ever as perfect as we would like. And one of the things with the RV-10 that people, or 4-seat, that people really liked, we had great cabin space. It was really more spacious than we had even intended. The outward view, the field of view was superb to almost anything we had. So a lot of people said, man, I really like the RV-10, but I don't need 4 seats. So the idea here was to upgrade a 2-seat configuration to incorporate as many of the features that people found desirable in the larger airplane. So that there's definitely a similarity that the RV-10 definitely inspired this airplane, and it has, along with continual upgrades in the kit, even though, hey, it's matched whole just like its predecessor, it's still in detail superior. Every new airplane we've come out with has been superior in little ways that just too involved to properly describe. So it's made it already a very popular airplane, easier to build, more consistent, more utility, all of the above. And as already mentioned, as time goes on, we both through our own intuition and input from our customers from the field, we come up with ideas for making upgrades and improvement, which is always important. Safety has always been a concern of ours. Obviously, it should be with anybody flying, but within home-built aircraft, they historically were not always viewed as being the safest way to get into the air. From our perspective, it's like, well, why not? Why can't they be? So that's been our goal all along, is to make an airplane that has safe flying qualities, as well as structural integrity, all of the above. The other that we have been able to emphasize and support is the idea of training, transition training, so that people can move into this airplane rather than just blindly, as had been done in the past, particularly with single-seat airplanes, and get better acclimated to the airplane so that they don't bend things on their first flights. This is an example of continuing refinement. There's a power plant on the RV-14 shown here. That airplane had a higher horsepower engine limit or specification than our prior 2-seat airplanes. But even beyond that, though, over time, Lycoming has improved their 0390 injected engine And engine is part of it, and engine installation is another part of the formula, so that we're able to really optimize the installation to get better performance out of that airplane around the top of the line engine. Just more detail on getting the performance out of the engine was the incorporation of a little larger air body for the fuel injection system, which permitted the engine to breathe a little better, develop a little more power. Exhaust system, that's part of the engine breathing formula. Air's got to come in and go back out, and you make that whole process as efficient as possible. And the engine cowling is part of the formula also, because you got to move cooling air around that engine, and it takes energy to do that. The better that can be managed, the lower the drag, and thus the higher the performance. Overall, our engineering team really excelled in this, not experiment, but this, in that we picked up, and maybe you can correct me on this, Greg, about 13 miles an hour
13 miles an hour
on
exactly.
speed.
Yep.
Speed is hard to come by in the real world. I should pick on Greg as an advertising guy, that it's easy to come by speed. You just sharpen your pencil, but in the real world, to gain 13 miles an hour on this airplane, if you did it with horsepower alone, it would take around 50 horsepower to gain that speed. The engine, we had only 5 horsepower more specified. Real world, we got more than a 5 horsepower boost with that installation. But a lot of the benefit there was refinement in the other details I just mentioned here, the engine cooling. This drawing shows a cowl flap down in the lower right. That is a cowl flap, or a cooling flap, I should say, incorporated in a cooling tunnel in the fuselage, not just a flap on the cowling as is often seen. That can be closed in flight to reduce the drag and achieve the speed gain that we found possible. Oil cooling, changes, improvements made there to keep this high output engine cool. The future of vans, well, who knows? We just keep doing what we have evolved over the years and just improving upon it. There's, as I kind of referenced before, we had achieved matched hole tooling and assembly some years ago, but we continue to upgrade that and make it even easier, such as, I think I missed one of the points on the slide here, that we got it so accurate that we end up now with final sized holes, not just approximations that have to be reamed to final fit.
And also so accurate with final size holes that if you ordered a part on an RB14 4 years ago and you wanted to replace that part today and you ordered it, the one that we ship you today would fit exactly.
Yeah. No, it's they're just, and going back personally to my design and manufacturing experience almost 50 years ago, I can't keep up with all of this. It's just the young engineers I've just had to stand back and let them do their thing with all of the magic tools that they have available now. But we will continue to work with that, both from design and manufacturing perspectives, to just make the best product available. This has always been a factor on home-built aircraft. Coming up with a final product that performs well, etc., is only part of it. The big part of it is that it has to be something that a reasonable person in the field can build. So that almost is, it really is the bigger challenge than designing a good airplane is designing a good kit. An example here of the cowling I made reference to before, with the accuracy they're able to achieve in the development of the tooling for that, it just makes it. Often on cowlings and set pieces, there's a lot of cut and fit necessary, and we've minimized that really to the benefit of the builder, because not only does it take time, but it's often frustrating. And if you're cutting and fitting fiberglass pieces of a cowl, you can overdo it, etc. So all of this is taking as much of the guesswork out of the process as possible. Another new tool, finite element analysis. From the engineering standpoint, you can put the computer sees this stuff in 3 dimensions. You can input known forces and loads. In the computer, you can see this part actually bending and moving as it would in service. So you can see where the high stress areas are. We're able to use this to manufacture parts that are going to hold up over time and give the consistent strength that we need. Testing, shown here, doing load testing on a wing. It's a very involved process, really. Often we're used to seeing pictures of airplanes being tested with big stacks of sandbags, which is okay, but this is with the shot bags, and showing here a fuselage at an attitude similar to what a high a pull-up stress load would be. Another picture drop test of on the landing gear. We repeated that many times. RV-14 in this case, and the 14 has really been designed to FAR Part 23 standards. In other words, the same standards that manufactured airplanes. We don't have Part 23 certification because designing and testing to that is one thing, convincing the FAA is another thing, a very expensive, time-consuming process. Picture here showing airflow tough testing. Another valuable tool that we've been able to use, as well as a lot of builders, is the video camera technology available now. Way back when, the only way we had to take a picture like this was to fly real close to the other guy, and it didn't work that well. This, though, if you notice, all of the tough tests on the lower fuselage of the RV-14 are pretty straight, indicating that really done a good job of controlling the airflow and minimizing the drag. I guess, hey, that's just about the end of it. Well, as the slide says, do you have any questions, or do you have the answers for us?
All right, so I have a question coming in from Mike, and he says, does Van's Aircraft have any educational programs available for EAA chapters, schools, etc., to get students building components as a way of introducing aircraft maintenance and engineering to students?
Van's Aircraft doesn't have anything specific to that. There may be little, such a program is really pretty involved. We have been involved, I personally have been involved. We initiated a project here about 10 years ago where, along with RV-12 Light Sport, which is the best product we have for entry-level builders, started a project working with high school kids along with a local nonprofit, aviation education related nonprofit, building a complete RV-12 with a volunteer group of high school kids. And we've done, I think we're finishing our 6th airplane right now with that many successive classes. And this concept has been copied by quite a number of other groups around the country. So it's pretty successful. Van's Aircraft supports that by offering discounts to the qualifying student groups that are doing it. Not to my knowledge, any real package that we can send out. You might refer, Greg, to the other practice kits that we have.
Sure, we do have certain kits which are great for doing the initial learning. There's like a small airfoil design, some other sheet metal practice. There's a great weekend project where you can build kind of like a internally lit sign with the Van's Aircraft logo on it. Those are all good learning for families and whatnot. We also on our website have a STEM, science, technology, education, math education page. The Teen Flight program that started here a little over 10 years ago that Van's involved in that he mentioned spawned a whole bunch additional similar programs, and there have been right around 100 or so kits ordered and either finished or being built right now, RV-12s around the world being built by teenagers. And so there's links to some of those programs that are on that page. So while we don't have a specific curriculum that we've developed, there are a number of organizations out there that have and that are willing to share that curriculum and are able to help facilitate builds at schools for some of the organizations and other organizations maybe outside of schools.
Other questions?
No, sir, that'll be all I have for you.
Pardon me?
That was it.
Really? Well, either I put a lot of people to sleep or we answered the question covered it so thoroughly, there aren't any more. The one thing that I didn't emphasize a whole lot, and Greg is a little more familiar with, and that's the whole RV community, the whole, I don't know any better way to describe it than that, fraternity or brotherhood or sisterhood. Any further comments about what we're doing to promote that?
Well, I think, when we talk about the Van's Aircraft family, of course, we talk about our business. We're a relatively small business, right? And quite close, but the Van's Aircraft family really extends to everyone who builds and flies the airplanes. And when you go to an airport, it's not uncommon at all to see one or more RVs. Some airports you go to and there's close to 100 RVs, literally. So there's a real brotherhood and sisterhood, sort of a family atmosphere, among the people that build and fly the airplanes. And it's something that we're both really happy and excited to be part of and also really proud of. And so what that really means for somebody who maybe hasn't built an airplane but wants to is that there's a lot of people out there who are both very capable and more than willing to help answer questions or come and look at a project or drive rivets or do a variety of things. So it's, the community is, half of what's driven Vans over the last 50 years. And that's because they're really cool, really fun, amazing airplanes. But, a common person, a typical person can pick up the tools, learn how to use them, put them together, join the family, and be part of a community that that fundamentally really transforms and changes people's lives once they get really involved.
Yeah, and this has been around in aviation before Van's Aircraft. I mean, the Bonanza Society, the Cub Air Forces that develop at different places, et cetera. But it just seems that we've been able to attract builders that really want to, that have the community spirit, really want to help each other, et cetera. And I guess we're kind of running out of time now. Hopefully that you've enjoyed this. I've really enjoyed the opportunity to speak to you, and just that look into our airplanes. If it seems like it's something that you'd want to be involved in, give us a call. Greg is all ready to talk to you here. So we'll call it a day. Thanks for listening.